Hello again, Algebra class. I hope you all are doing well. This is the last section of new material in Chapter 8. I am not sure if we'll go ahead and do the review and the chapter test this week also, or wait until 2 weeks from now when we get back from our spring break. All right, so this section is the toughest as far as factoring, but I have great confidence that you all will catch on. We are going to factor polynomials. This is called the general form of a polynomial, or standard form, ax squared plus bx plus c. The a, the b, and the c, of course, stands for the coefficients and the constant. So as to now, we have only been factoring trinomials where the a has either been 1 or -1. And now we're going to factor trinomials where that a, that leading term, is not 1. And it just makes it a little bit trickier. The method that we use is guess and check. If you look at this, there are no two numbers that multiply to 3 and add up to 7, correct? It's because of this 2, and that changes everything on how we do it. So the way we begin with these is begin with your 2 sets of parentheses. I like to look at my signs first. If this last sign is positive, we know that these 2 signs must be the same, either both positive or both negative, because our L in FOIL, they're going to multiply to a positive 3. We look at the middle term, which is negative, and we know that these 2 numbers are going to, or the 2, the outer and the inner, are going to add up to a negative. So anyway, we know that those 2 signs will both be negative. Now, in the beginning, the first term, 2x squared, we can't just put x and x, right? That would not multiply to 2x squared. So one of these terms must be 2x, and the other is x. Now we know that our first term is going to be okay. Now the last 2 numbers here, our p and our q, must be factors of 3, so that can only be 3 and 1. Now here's the tricky part. We don't know if the 3 goes here and the 1 is here, or vice versa. So we guess. I'm using a pencil because we often have to erase things, change them up. So here's our guess. How do we check? Our check is to find the outer term and the inner term and see if we get a -7. So let's check this. Our first term, of course, is fine, and our last term is fine. So the outer and the inner in our FOIL, outer would be -2x, and the inner would be a -3x. And when we combine those, we would get a -5x, which is not going to work. So we need to switch these numbers around. Let's put the 1 here and the 3 here, and then let's check this. So we do the outer again, which is -6x, and the inner, which is a -1x, and there we get our -7. So this would be the correct factorization of this trinomial up here. We would be done. Guess and check. And don't forget that some polynomials are prime. They cannot be factored. So that's when it gets a little confusing. But that doesn't occur too often in math class. It occurs more often in real life. All right, let's do another one. So we're going to start with our parentheses. We notice our A is not 1, so we have to use guess and check. Let's do our signs. Since this is a negative sign, we know that our signs, one's going to be plus and one's going to be minus. We're going to have opposite signs. Again, I'm doing that in pencil because those signs might change. In our first example, they both were negative, so I didn't have to worry about them changing. But if we have 2 different signs, we might have to switch them. You'll see in a minute. All right, so let's find 2 terms that multiply to 3n squared. So that would be 3n and n. And then now the factors of 5. 5 is prime, so we only have 5 and 1. So that's a guess. Now let's check. Our outer term would be negative 3n, and our inner term would be a positive 5n. When we add those, we get positive 2n. That's not what we want. So we need to switch these numbers around. So let's put the 1 here and put the 5 here. And then now let's check and see how this works out. The outer would be negative 15n. The inner is a positive 1n. Negative 15 and 1 is negative 14. We want a positive 14. So as long as we have the right number, but the sign is wrong, we just need to change the signs. So this should become a plus, and this should become the minus. Now let's check this. We would have a positive 15 now, and a negative 1, and that gives us our positive 14n. So we use guess and check for all of these problems. All right, there's a guided practice in your book on page 536 at the top. I would encourage you to pause the video right now and try those problems. So here's number 1. Factors into t plus 2 and 3t plus 2. Number 2, s minus 1 and 4s minus 5. And number 3, h plus 7 and 2h minus 1. The more you practice factoring, the easier it becomes. Moving on to example 3, we're going to look at some of these problems when a is negative. So our practice is always, if your first term is negative, you want to factor out the negative 1 first. So let's go over here. We have a negative 5 is our a. So let's pull out the negative. That would leave us with 5b squared minus 7b plus 2. Now we don't have a 1 for our coefficient, we've got a 5, so we have to do guess and check. Bring this negative sign down front. We're just ignoring him, but don't forget about him. This sign is a plus, this sign is a negative. Do you know what our signs will be then? The factors of 5 are just 5 and 1. The factors of 2 are 2 and 1. Now this is, I'm already going to lead you to the next step of guess and check because you guys are pretty bright. You can almost, without writing it in, some of you might be able to put the number here, put the 2 here, you'd get a 10. Put the 1 here, you'd get a 1. 10 and 1 is 11. That's not going to work. Put the 2 here, put the 1 here. The outer would be negative 5b. And the inner would be negative 2b. And that gets us our negative 7b. So this would be the factorization. So that method is called an educated guess. If you want to write it in with pencil because you're new at this, that's perfectly fine. But eventually you kind of want to do some educated guessing there. All right, our next example, we have the negative, so let's pull that out. 4x squared minus 12x minus 7. Now this presents us with a problem. Do you see? Well, not a problem, but a unique challenge, let's call it. So far, our a and our c terms have all been prime numbers. 4 is not prime. What does that mean? That means that we've increased the number of guesses that we might have to do. So this could be a 4 and a 1, or it could be a 2 and a 2, and we just don't know without trying them all. So let's grab the pencil again. Well, first we can do our signs. Since our signs are different, I'm gonna put our signs in pencil. And let's just check 2x and 2x. And then the factors of 7 are 7 and 1. Do you see how I want more negatives? I'm going to put the 7 here and the 1 here. This is just a guess. Now let's check it. The outer would be negative 14 and the inner is plus 2. Oh, that was a very lucky guess for me. It works out to negative 12. So on our very first guess, we lucked out. If we would have tried the 2x and the 7 and the 1s didn't work, then we'd have to go to 4x and x. So it just gets to be a little time consuming. Okay, there are some more guided practice problems on the bottom of page 536. I would suggest, highly recommend, pause the video and try those 4, 5, and 6 on the bottom of page 536. Okay, and here they are. Number 4, y plus 1, 2y plus 3. Don't forget the negative out front. Number 5, m minus 1, 5m minus 1, the negative out front. And number 6, negative x plus 1 and 3x minus 2. Okay, now I'm going to show you a method that is not covered in your book, but it's a pretty neat thing that we can do, that we can use. It's called the AC method. And we want to use the AC method when your A and your C have several factors. This one was not too bad, but you can see how it might get a little annoying there if we have A's and C's that have many factors. All right, here's our first example. 6y squared minus 5y minus 4. We want to factor this trinomial. Well, 6 factors into 6 and 1 or 3 and 2. And 4 is 4 and 1 or 2 and 2. That's a whole lot of guessing and checking that we have to do. So here's the AC method. You begin by drawing an X like this on your page. These X's are going to hold 4 numbers. The top is where we will put the product of A and C. In the bottom is where we put our B term. So A times C is a negative 24. So we write a negative 24. Our B term is a negative 5. And then now we play the game that we played in the very beginning. We want to find 2 numbers that multiply to negative 24 and add up to negative 5. Did you guess negative 8 and 3? And if you put the 3 here and the negative 8 here, it doesn't matter. Negative 8 and 3, they can switch. Now here's a little tricky business. I hope you're ready for this. We write the first term exactly as it is, it comes down. So we have 6y squared. Now we use these 2 terms, these 2 numbers, and put a variable with them. So we've got negative 8y plus 3y. And then we bring down the C term as is. Minus 4. When you look at this 4-term polynomial, and you know how to factor this, we're going to factor this now by grouping. And that's why I did that lesson on factoring by grouping before this lesson, because I wanted you to be familiar with that. So how do we factor this by grouping? We take the first 2 terms, we divide out the greatest common factor, which would be a 2y, 3y minus 4. And notice over here, we have already 3y minus 4, so that's like a 1 in front, and 3y minus 4. And then from here, we take the common factor, which is 3y minus 4, And then we pick up what's left. 2y plus 1 goes in the other. And you have factored this trinomial. If we FOILed this, 6y squared plus 3y minus 8y gives you a negative 5y minus 4. All right, let's try it one more time. 4a squared plus 9a minus 9. So let's use the AC method. On the top goes the product, A times C. On the bottom goes our B. A times C is negative 36. B is 9. What two numbers multiply to negative 36 and add up to 9? Well, that's going to be 12 and 3. And I want a positive 12 and a negative 3. Now we rewrite the polynomial. We bring down the first term. So we have 4a squared. We create a term with this number, plus 12a. Create a term with this number, minus 3a. Bring down the c term, minus 9. Then we continue factoring by grouping. So the greatest common factor of these two terms is 4a. This will be multiplied by a plus 3. And note, when you're looking at this, you want to be left with an a plus 3. So that's a good hint to let us know that this has a common factor of negative 3, a plus 3. Pull out the term that's common to both, which is a plus 3. Pick up what's left, 4a minus 3. And then if you wanted to, you could FOIL this. You will get the original trinomial. So I would recommend watching this video again if it seems a little clumsy. Personally, this is a method that I'm not that familiar with, but the more I do this, the easier it becomes, and it really is a time saver in the long run. Okay, moving on to example 5. This is in your book on page 538. This is a great example of how we would use this skill in the real world. We have a rectangle whose length is 13 meters more than 3 times its width. The area is 10. What is the width? So what is the width? Let's just call that W. Its length is 13 more than 3 times the width. And the area is 10. And we know that the area of a rectangle is equal to length times width. So let's go ahead and rewrite this equation. The length times the width, I'm going to write the W first. We want that area to be equal to 10. Okay, we are going to have a quadratic. We go through the steps. We're going to distribute. You get 3w squared plus 13w. We're going to subtract our 10 because we have to have it equal to 0. Now we want to factor this. This with the 3, and you've got a 10 and a 5 and a 2. You could guess and check, or you could do the AC method. I'm just going to give myself a little bit more room to do the AC method. A times C is negative 30. B is 13. Ask yourself which two numbers multiply to negative 30 and have a difference of 13. So that would be a positive 15 and a negative 2. So if we rewrite our quadratic with four terms, we have 3w squared plus 15w minus 2w, write the c, minus 10, and we're going to end up solving this. Now let's factor using grouping. 3w times w plus 5. And then looking at this, and I want to get a w plus 5 left, kind of helps me out that I know I've got to take out a negative 2 w plus 5. So I have w plus 5 times 3w minus 2 is equal to 0. Now I want to iterate again. This is different than just factoring. We want to solve, so we have to continue on and apply the zero product property. So w plus 5 is equal to 0, or 3w minus 2 is equal to 0. If we solve this, w will equal the negative 5. In the context of this problem, w stands for the width. We can't have a negative width. And here, if we add the 2, divide by 3, w would equal 2/3. I don't know if it's meters, meters. So that would be the width of that rectangle. The last example, I know this is a longer video, a lot going on here. The last example is pretty quick. If you are given the roots, the zeros, or the solutions, you should in turn know how to write the polynomial. All right, so if you have, let's take a look at this here. Do you see how we had a factor of w plus 5? And that led us to a root or a solution of w equals minus 5. Notice the compare and contrast this with this. The signs are different, correct? So here, if you have a root, a 0, or a solution that's 3, what would the factor look like? What would the factor look like that would get you x equals 3? That would be x minus 3, correct? Equal to 0? And if you had x equals negative 1, what would the factor look like? X plus 1. So the relationship between roots and zeros and the factors are, the signs are different. And in fact, your factor is always x minus r, the root. X minus a negative gives you your plus. So what would the polynomial be that has these roots? Well, it's going to be factored like this, and then we just simply FOIL. So if you FOIL x minus 3 times x plus 1, first, x squared, outer is x, inner minus 3x for a total of minus 2x, and last, negative 3 and a positive 1, negative 3. Given the roots, find the polynomial. All right, take care. Again, if anyone would like to meet with me in Zoom, just special request that in the classroom stream. This week, I will be checking the classroom communications, especially between 9 and 10 o'clock every morning. All right, take care and God bless.